come to the next topic, which is thrust and pressure. So students, have you ever wondered why a camel can run in a desert easily? Cutting tools have a sharp edges. So students, in order to address these questions and understand the phenomena involved in this, force acting on an object perpendicular to its surface, and its SI unit is Newton. Now let's talk about the pressure. Pressure is what but nothing than the thrust per unit area. SI unit of pressure is Pascal or Newton per meter square, and the formula of pressure is thrust per unit area. Acting on a smaller area exert a larger pressure, and they exert a smaller pressure on a larger area. This is the reason why a nail has a pointed tip, knives has a sharp edges, and buildings have a wide foundations. I hope this one is clear. Now let us talk about the pressure in fluids. You all know that all liquids and gases are fluids, and a solid exerts pressure on a surface due to its weight. Similarly, fluids have a weight, so they also exert pressure on the base and walls of the container, right, in which they are enclosed. Pressure exerted in any confined masses of liquid is transmitted undiminished in all directions. So from this, you can say that fluids have a weight and exert pressure on the walls and the base of the container in which they are enclosed. You can take the example of thumb and pin. While pressing a pin on a table, your thumb exert pressure on the pin, and in this case, the more pressure is exerted on the pin as compared to your thumb. Your school bag has a wider strips. Why they have larger strips, or why they have thicker strips? Because if the area is larger, then automatically the pressure which the object applied on you becomes less. So if the school bags has wider strips, it has more area, then automatically the pressure it exerts is less. So students, have you ever had a swim in a pool and felt lighter? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and steel does not sink in a seawater? But while the same amount of iron and steel in the form of sheet would sink? So let us discuss about these answers in detail. So these questions can be answered by taking buoyancy in consideration. So buoyancy is basically the upward force exerted by water on any object. You can take the example of water bottle. You can take the example of any paper, leaves. So this is basically termed as a buoyant force or upthrust force. Whatever the force exerted on that particular object is called buoyant force or the upthrust force. So any object immersed in a fluid experiences buoyancy. Buoyancy depends on the density of the fluid. What is density, students? Let's take the example of water bottle. If you lie the water bottle in a bucket of water, what happens is that water is immersed in the liquid. The upward force exerted by the water on the bottle is greater than its weight, right? Because your bottle is empty. So the upthrust force which is exerted on the water bottle is greater than its weight, and therefore it rises up when it released. To keep the bottle completely immersed, the upward force on the bottle due to the water must be balanced. and this can be achieved by externally applied force acting downwards, and the force must at least be equal to the difference between upward force and the weight of the water. So students, this question is for you all, that why objects float or sink when placed on the surface of the water. Let us take some example to understand this concept clearly. Why the nail sinks in the water, and why the cork float while the nail sinks? So the reason behind this question is, the nail sinks because the force due to the gravitational attraction of the earth on the iron nail pulls it downwards. There is an upthrust of the water on the nail which pushes it upward, but the downward force acting on the nail is greater than the upthrust of the water on the nail. So it sinks. But in another situation, the cork floats. This happened because of the difference in their densities, and the density of the substance is defined as the mass per unit volume. The density of the cork is less than the density of the water. This means that the upthrust of the water on the cork is greater than the weight of the cork, so it floats. The density of iron nail is more than the density of water. This means that the upthrust of water on the iron nail is less than the weight of the nail, so it sinks. So student, therefore, the object of the density less than that of the liquid float on the liquid, but the object of the density greater than the liquid sink in the liquid. So from this situation, we can conclude it as the density is basically the mass per unit volume, and the SI unit of density is kilojoule per meter cube. It is different for different substances, and it is helped to find purity of the substance. We can also talk about the relative density, in which the water is taken as a reference to define the density of the substance. Ratio of density of substance to the density of water is known as the relative density. It is a unitless quantity. Let us talk about the relation of buoyancy with density. Higher the density of the fluid, higher the object floats over it, because the buoyant force is directly proportional to the density. As we have read about this topic, I hope this is clear to everyone, that why does the object float or sink. So the gravity pulls the object, and the upthrust force is acting on the... Let us conclude this topic. Objects of density less than that of a liquid float on the liquid, but the object of density more than that of the liquid sink in the liquid. I hope it is clear. Now. Let's come to the last and the final topic of this chapter, which is Archimedes' principle. So, Archimedes' principle: when a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. If you are immersing any stone in a liquid, what happened then? Volume of water which is replaced from the container is equal to the mass of the stone. You can take the example of stone and water. In this case, the water which is released from the container is equal to the mass of the stone. So from here we can say that the mass of a stone is equal to the volume of water released from the container. Now let us talk about the applications of Archimedes' principle. So the first applications of Archimedes' principle is it is used in designing ships and submarines. It is also used in lactometers. What is lactometer, student? Lactometer is basically used to determine the purity of a sample of a milk. And this application is also used as, and this principle is also used as an application of hydrometer. Hydrometer is basically used to determine the density of the liquid. I hope this chapter is clear. I hope this chapter is clear to every one of you. Thank you so much. Thanks for watching. Do like, share and subscribe to my channel. Thank you so much. See you in the next video. Until like, share and subscribe to my channel.